Hello everybody, this is Professor Khan, and in this video I would like to go over how to do a wall insulation calculation if needed. I'll do an example and maybe you can practice a little bit, but it's not going to be very difficult. So let's think about it a little bit. So if you would like to calculate the heat loss from a wall, I don't know if you can see that. I'll change the pen. So we said Q. Okay, it's not working here. Technical difficulties. Okay, Q equal area times U times delta T. Okay, so let's say that we have a wall with R value equals let's say 6. Just an example. So we know that U equal 1 over R, and let's say the wall area, for example, is 140, just for an example, and delta T is 70. Okay, so let's try to calculate that heat loss. So it's going to be, if I use my calculator here, 140 times 1 over 6 times 70, and that heat loss turned out to be 1633 BTU per hour. So let's say I want to reduce that heat loss. I would like to add some insulation. What should I do? You probably thought about increasing the R value by adding insulation. When you go to Home Depot or Lowe's and try to buy insulation, you're always going to look at the R value per that insulation. So let's say, how much insulation do I need to add? For example, if I want to reduce the heat load by 50%, reduce by 50%, meaning that I want to cut it in half. So that's 1633 over 2. That's half, right? Equals what's 16? Oh, I'm doing it by calculator so I don't mess it up. 2 is 816.5 BTU hour. And let's say again, I did put in the PowerPoint an example of how to do percentage. So 1633 times 0.5 is going to be the same thing, or also you can say 1633, and there's a percentage button here sometimes, I don't know where it is, but there's usually a function that does the percentage for you. But anyways, you get the idea, is reduction of as a percentage of the heat loss. So let's say that's the new heat loss that I want. I would like to resolve this equation and manipulate it to look like it is solved for insulation. If you look at this sheet, and this sheet is available on references, and it's also available in the back of the book that's in Blackboard. You see this equation here that says R insulation equal area times delta T over Q minus R wall. This will give you the resistance you need to achieve that insulation. So how did this come about? I will just do some manipulation over here just to show you how it came through. Throw this away. So if we look here, Q equal A times 1 over R times delta T. If I want to solve for R here, I will manipulate this to be Q divided by A divided by delta T equal 1 over R. If I want to flip both sides, it's going to be A times delta T over Q equal R over 1, which is R. So R equal area times delta T over Q. And you know, if you want to have R total, it's going to be R wall plus R insulation equal A times delta T over Q. So if you want to get the R insulation by itself, so R insulation will equal A times delta T over Q minus R wall, which you'll find this function over here already typed, so you have to only fill in the blank to get the insulation. So if I want to do this example here now, and I want to solve for what R insulation that is needed for me to get a Q of 50%, which is 816. I'm gonna just avoid the half, so I will go with R insulation equal area times delta T over the new Q minus R wall, and fill in the blanks. Area was, I forgot already, that's 140 times 70 degrees over the new one, which is 816.5 minus, what is the R wall here, was 6, and this is R insulation. And if I do the math, make sure you keep the parentheses here. So if I do the math here, where's my calculator? You always use a calculator, at least to double check your work. Over 860.5, that's 11. So I got 11.37 and minus 6 our insulation, and that will be minus 6. So it's 5.3. That's going to be your insulation. That's insulation resistance. And if you notice, it's 5.37, so it's almost 6. And if you think about it again from mathematical point of view, if you would like to reduce this by half, you have to add something in the insulation. So it's kind of, you double the insulation to get half the heat loss. So hopefully this makes sense, and feel free to watch it again and do a few examples to know which is the required insulation. Okay, I'll pause this and see if you have any comments on the video. Thank you.